Well, I've taken apart my circuit, leaving the sleep circuit over there, because that's the shorted sleep circuit, the 6.6 gigaohm, Becker style circuit that's shorted across its terminals. That I've hooked into this, and so I'm trying to upgrade it because these are the capacitor plates, and there's the quartz crystal down there, and then the two toroids wound and hooked together. And so what I'm going to try to do is make a circuit diagram, but I'll do an upgrade at the same time. And the idea is I don't have thick cable, multi-stranded cable wire. All I have is this 18 gauge multi-strand wire, and it's not a whole lot of wires. It's just a few, so I don't know what to do. And that's not multi-strand wire, that's actually copper clad aluminum wire. So what I thought I would do is create a continuous loop of wire that doesn't go to anything. It just goes on itself. Because this wire, actually, I have connected, looped to itself. In fact, that's what the green alligator clip jumping wire is. It's a short, so that it makes a continuous loop. So the wire goes around one toroid counterclockwise. This one on top is counterclockwise. And then the one underneath is clockwise wound. And they're connected in series, and then they're shorted, so that I get a continuous loop going around them. But that's the primary, because that goes, one end goes to my earthing bed sheet, one connection, it's like two center taps, oops, and the other goes out, whoops, the other goes out the window to a grounding rod. So I already have a continuous loop, but it goes around the toroids as a primary, and so now what I need is a secondary that just goes through it once and coils on itself. And since all I have is this 18 gauge wire to use, I'm going to use that. But in the meantime, I'm going to make a diagram of how all of these things are put together. This homemade stack of capacitor plates, what you see on top is just bare glass. That's like an insulator, and I have one on the bottom as well. Underneath that, I have the contact plate, which is another glass plate sandwiched with aluminum foil on both sides, and then it overextends, and then I curl them together to create a solid sandwich surrounding that entire glass plate. So that's my contact plate. So I have two capacitors there that are interleaved, plus a floating plate in the middle. And because of their interleaving, in order to get the polarity straight, I had to have a floating plate in the center. And the reason why I have two is because each one is matched to its corresponding toroid. That's why I have two. So I have two tank circuits in a sense. The trouble is I'm shorting across the center of the tank circuit, I think, or somewhere. That's why I need to do a diagram at any rate. And then the two capacitors end up going in chain link fashion to the quartz crystal, to either side of the quartz crystal. Not quite sure. I'm going to have to draw it out, obviously. So I'm going to take the 18 gauge and go through there once, and come out and loop it on itself a few times. And I don't have much here, so what I think I'm going to do is add more wire to it. So I got some wire left, and I'm going to add this to it. And then I got male and female connectors. These are the males. What I could have done was taken this and bundled it and to create a multi-strand of sorts. The problem being I've got all this insulation in between each strand. I could do that too. I might have enough wire. I may want to try to use up all this wire and see how to do that. So I'll have to take a guess how many self loops on itself I want to do in order to get away with how many strands I want to bundle together to create a multi-strand, to try to increase the number of strands. That's what I should be doing, to fake a larger gauge wire, basically. You know? Okay. So the first thing I'm going to do is I'm going to map this out. I'm going to draw it out, all the connections, and that way you'll have an idea of how I did it. Those are floor flanges. It looks like 9 inches across with a 3-inch diameter hole in the middle, but 9 inches across the entire diameter. And they're not zinc plated. They're not galvanized. Got them online. I can't remember where. It's a place that a lot of people... Granger's. It might be Granger's. Yeah, it might have been Granger's. If not, it was somewhere else. They're just floor flanges, cast iron, you know. Nothing special, but I needed a cheap alternative to expensive transformer cores. I mean, I went there first, but the prices were exorbitant, so I had to stay within a budget. These glass plates, they go to picture frames. They're 5x7. You get them at the hardware store or maybe the 99-cent store. I got these at the hardware store. They had them all by themselves, without the picture, without the frames, just the glass, a whole pile of them. So I just picked out glass that wasn't chipped and took it home and, you know, wiped it off, rinsed it, and dried them all, you know, took baby care of them. And I got tons more. So I can make all the capacitors I want to, if I'm willing to do it this method with aluminum foil, which incidentally is not pure aluminum. Aluminum foil is wax paper with aluminum coated on both sides. And it's so thin, if you bake with it, you'll literally get holes in the wax paper because the wax, in the aluminum foil, because the wax paper substrate has melted. And the aluminum foil, I don't know where it went. And so I gave up cooking with the stuff because I thought, well, I don't want that on my food if the thing's going to melt on me. So the only thing it's good for is to give away to other people if they want to use it, or use it for capacitor plates. So, how much aluminum foil does it take to make a capacitor plate? Not a whole lot. Not a whole lot. And then I have clip leads connecting each one. So when I roll the edges and crimp them, flatten them, then I seal it with masking tape, but I leave one spot bare for the connection point. So that's what you see. Here, I left it bare to connect the clip lead to it. So it works pretty good. And if you want to make a prayer plate out of them, then you write your affirmation on the glass with a marker, with a waterproof marker. I've done that too. I've done all kinds of things. Prayer plates, okay. Give me more. You're right. Okay, time to diagram. Okay, I finally have the diagram. I just don't have a pointer. So, well, that's not the best pointer in the world. So the way this works, here's the CCW. There we go. And the bottom of the CCW, they're sandwiched together. Their bottoms are sandwiched together and their tops face out. That's what I have over there. So, the bottom of the CCW goes out. And it doesn't matter to me whether the out is the grounding rod or the earthing bed sheet. It's either one. So the bottom of this, it might make a difference, but I don't know if it makes a difference. So the bottom of the CCW goes out, and the top of the CW goes out. So it's reversed for some reason. I don't know why. there are two shorts to make an entire loop. So I've shorted the top of the CW that goes out with the top of the CCW which goes into the capacitor plates. Meanwhile, I have another shorting cord drawn around here, the perimeter, that's attached to the bottom of the CW and the bottom of the CCW. So the shorts match. The top of the CW is shorted to the top of the CCW, and the bottom of the CCW is shorted to the bottom of the CW. But whether they go out or in is an entirely different thing. That's the thing that's opposing. So at least I had these matched when I shorted them. Top to tops, bottom to bottom. So I'm shorting the bottom to the bottom and the top to the top. And that's the way they're sandwiched. They're sandwiched bottom to bottom. So that makes sense. But it's the top of the CW that goes out. And it's the bottom of the CCW that goes out. So, where does everything go? Well, the bottom of the CW goes to this plate here that's one that's, not the outermost plate, it's one in. And in terms of capacitors, this plate, this connection is matched to this one down here, because that's the way the interleaving works. So this one matches to this one in terms of a single capacitor, and then this plate here is matched to this one here, so that the polarity is correct. You'll do it yourself. Maybe I'll do it afterwards. When I get done with this, I'll write in the polarities. I could do that now. Yeah, why don't I do that now? So during any particular phase, or just you pick a DC current, whatever, in order to map out the polarities. So why don't I do that? Okay, so the squares represent a single capacitor, the circle is the other, and this one is the floater that's not connected to anything. So this is what interleaving does. It puts 2 here and then 2 over here. And if you look at the polarity, the square ones, one has to be positive, the other has to be negative. But because of interleaving, this one has to be negative adjoining this one, and that's why we need a floater in between. And so as you can see, in this particular phase, of these 5 contact plates, 3 are positive and 2 are negative. And if it were the opposite polarity, it would be 3 are negative and 2 are positive. So you always have a dominant situation. But that's how you stack them to get them into phase lock. At least that's the way I chose to stack them. Maybe there's another way, by putting a floater in the middle. So let's back up and take a look again at the connections. So the bottom of the CW goes to this plate here, and it's matched, which one is it matched to? This outer one here, which goes to the top of the CCW. See? So the first capacitor is connected to the toroids, and the other capacitor is connected to the quartz crystal. That's the way I had it. No, excuse me. Did I do that right? Oh, shoot. Wait a minute. Let's... This one goes to here, which means this last one goes to here. Okay. Oh, you know what? This isn't drawn correctly in terms of the flow. If we were to separate these two capacitors, really what it is the quartz crystal is in the center. There's a capacitor on either side. and then there's a toroid on the outermost ends of this linear arrangement. I just folded everything together using the quartz crystal as the center of the fold, or as the fold line, I should say. And then so the capacitor that was here goes on top of this one, and the toroid over here goes on top of that one. And so because these are actually sandwiched, that's why I have it arranged this way, because it's been folded, the fold line being the quartz. And that means I get to put these into phase lock, and in a sense these, because I put one on top of the other. So that's why it's so confusing. Oh boy. So let's go back to, let's see, the quartz crystal. This one matches to the outer one, and that's what happened. So one capacitor, the two ends, see what happens is I have the quartz, and that's the other thing. If I was to unfold this, the quartz crystal would turn around. It should. So that one end goes to the plate, the leftmost plate of this capacitor plate, and then the rightmost plate of this capacitor plate would go to the toroid, and then the toroid would go to the outside connection. Likewise, the capacitor here, this is turned around, so the leftmost connection of the quartz crystal goes to the rightmost plate of the capacitor plate, and then the leftmost capacitor plate goes to the toroid, and then the other connection of the toroid goes out. And that's the way I have it linearly set up. I guess I'll have to draw that. But then I've folded them to get the capacitors together, and then so I had to put in a floater, and to get the toroids together. That's why it looks so screwy. So what I'm going to have to do now is transpose this diagram directly to an unfolded condition. So there won't be the floater, and then you'll be able to see what this really is, and then include the shorts, because right now this is like a mess. But this is what the final product is once you've folded everything together, to interleave these and stack these. So what I'm going to do now is draw in the loop. The loop that's going to go through the holes of this, because these are stacked together, and so it'll go through once and then be looped on the outside. So actually I did this so you could see these connections here. It's really, do I have any room? No, I don't have any room. Oh, I threw in, wait, I'll get a piece of scratch paper, that's what I'll do. Okay, boy, it looks like the rings of Saturn. So this is going to be the 18 gauge wire that I'm going to try to create a multi-strand condition so that I can thicken up the wire a bit. And this is the continuous loop. I'm going to go through and this is the stacked toroids seen from one side of the stack. So you can't see the other toroid. One's behind the other, sandwiched together. And so I'll wrap this going through there and then coil it, and then make it continuous. And it's not. I'm not going to connect this to anything because I don't know what to do. I'm just taking this one step at a time. So I'm taking this as it stands. I'm taking this as it is, and then I'm going to add to it. Put these two toroids together because that's what they are. That's what they are in the box. I just had to separate them diagrammatically, and then put this through. And so now the other diagram I have to show you is what this looks like when it's unfolded. I've truly mixed this up. I've got one capacitor connected to the quartz, and that's all they are. It's a closed loop right there. And then I have both toroids connected to another capacitor, and that's another loop, a broken loop basically. Oh, like a tank circuit. So that was it. That was what I did. What I basically did was I made it a tank circuit out of the two toroids put together in series as if they were one toroid, because I want the CCW to counterbalance the CW to cancel 60 cycle hum. And so each one is around the same number of turns, presumably with the same length of wire. In fact, even when I cut it off, I try to cut it off at the same point so the ends stick out the same length. So that's why I only have one capacitor for both toroids. Then I'm stuck with putting a capacitor with the quartz crystal. That doesn't make any... Oh! So then I interleaved it in order to integrate the quartz crystal with the rest of the circuitry. So in a sense, the capacitors are a form of integration to get the quartz crystal to be connected, the two ends to be connected to the circuit in a weird kind of way, to end up like that. So it's not what I thought, because I was expecting that this plate would connect to one end, and this end would go to this plate over here, and this plate would go to the toroid, and that plate would go to the toroid. But that's not the way I did it. I don't know why. What I guess I'm going to have to do is try to figure out why that's the case. So I'll have to do another drawing and see then if I can fold it into this. And if I do fold it, I probably have to rewire it. Will it work out? And it may not. I don't know.